Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning for all participants. For this time, we will try to discuss about the other news model created by the Rado Institute Distribution, namely Generalized Inverse Power Rado Institute Distribution. We have success discussed about the three models created by the Rado Institute, like the Rado Institute Distribution, Power Rado Institute Distribution, and then Inverse Power Rado Institute Distribution. And now, for this time, we will try to improve the Inverse Power Rado Institute Distribution become to the Generalized Inverse Power Rado Institute Distribution. In the model Generalized Inverse Power Rado Institute Distribution, we have the three parameters, beta, alpha, and theta. It's so very different with the Inverse Power Rado Institute Distribution that only have the two parameters. The idea how to create the Generalized Inverse Power Rado Institute Distribution is based on the one research article that published in the international journal. Okay. From the one research article with the title Generalized Inverse Power Sujata Distribution with application, published on the Asian Journal of Probability and Statistics, there is one technique to improve the model, like in the equation 2. In the equation 2, there is the density function fx equal to beta multiplied by gx beta power beta minus 1 multiplied by fx beta. So from the equation 1, from the equation 2, we have learned if we want to create the new models, we can use the old density models. We can use the old density models, and we can use the cumulative old distribution model, and we try to using the new parameter beta and beta. We try to adding the new parameter beta. So you can imagine that if we try change this density function with the inverse power Rado Institute distribution function, and we change this one to become the cumulative distribution function of the inverse power Rado Institute distributions, then we can produce the model of generalized inverse power Rado Institute distribution. Okay, we have success discussed about what is the density, the inverse power Rado Institute distribution, and we have success discussed about the cumulative distribution function. We know that the inverse power Rado Institute distribution only have the two parameters such as alpha and theta. By the concept, like in the equation 2, we can give the ones, we can add the one parameters against, namely beta parameters to the model. So based on the equation 2, we can produce the new models, namely generalized inverse power Rado Institute distribution. Okay. Now to give the more explanation about what is the generalized inverse power Rado Institute distribution, we can use the R software, and we can do application the models generalized inverse power Rado Institute distribution using the sum data set. Okay, let's open the R software. Okay, this is our R software. This is this data set. We will use this data set to run the program, to run the modeling of the generalized inverse power Rado institute distribution, especially for the k equal to 3, 4, 5, and 6. Okay, for example, in this blue one, okay, you can find in the blue, I give the blue colors, okay, in the R's, you can find that in the blue colors. This is the model of the generalized inverse power Rado institute distribution for k equal to 3. Okay, the part 1 is the beta. Part 2 is the alpha, and part 3 is the theta. So from this model, okay, in the blue one, we will try to use the program, the log likelihood. This is the log likelihood, the coding of the log likelihood for the generalized inverse parameters for generalized inverse Rado institute, generalized inverse power Rado institute distribution for k equal to. This is the coding, the program of the log likelihood function. Okay, this log likelihood function. After we success to create the coding program for the log likelihood function, we try to using the optim tools. The optim tools, it means this is a program to estimate the parameters based on the numerics methods like the Newton Raphson method. Okay, and then we give the initial value 1 for the beta or the part 1, 2 for the parameter alpha or the part 2, and 1 for the parameter theta or part 3. Okay, we run the program. We run our program. Okay, so we try to find the result of this program. We type the GIS. GIS is for the estimate the parameter using optim for the generalized inverse power Rado institute distribution. Okay, so from this coding, we can find the parameter beta is 0.9. Parameter alpha 1.1 and the parameter theta 2.5. Okay, and then this is convergence come to 0. It means we are success using R software, and then we are success to create the good coding for the estimate the parameter, especially for the generalized inverse power Rado institute distribution for k equal to 3. Okay, after that, we give the all information, beta for the parameter 1, alpha for the parameter 2, theta for the parameter 3. We run this program, and this one density function, the real density function for the generalized inverse power Rado institute distribution. And we can next to our program to create the log likelihood of the generalized inverse power Rado institute distribution for k equal to 4. For k equal to 4. Okay. I give the blue color to show you this is the density function of the generalized inverse power Rado institute distribution for k equal to 4. Okay, you can find it in the blue one. So it's a fairly long equation. Okay, the very long equation. The parameter, this is the 4 parameter, of course. Okay, we can run the program. Okay, we can run the program. Okay. So if we want to know the parameter, we just type GEPR. Okay, this is the parameter. This is parameter theta. This parameter beta. This is alpha. Jadi theta. This is minus log likelihood, and this is convergent to number of 0. Okay, next we continue to the this is the program for the log likelihood of the generalized inverse power Rado institute distribution for the k equal to 5. Okay, you can check the blue one is the density function for the generalized inverse power Rado institute distribution for k equal to 5. Okay. Parameter 1 for beta, parameter 2 for the alpha, parameter 3 for the theta. Okay, we use Optim to the estimate the parameter. We run our model. Okay, we run our model. If you want to know the parameter, we just type the GEPR5. Okay, this is parameter. Parameter beta, parameter alpha, and the parameter theta. So very nice program. So next we come to the generalized power Rado Institute for the k equal to 6. Okay, this is a very long equation for the density function of the generalized inverse power Rado Institute for the k equal to 6. Okay, you can check in the blue one. The blue one is mean the density function of the generalized inverse power Rado Institute distribution for the k equal to 6. Okay, we use the programming. This is a program for the log likelihood. We run years, and then this is Optim to the estimate the parameter. We run years. Okay, so if we want to check the parameter, we just type the GEPR 6. Okay, this is parameter. This is parameter beta. This is alpha. This is theta, and this is minus log likelihood and compare again to number of 0. Okay, we have success run the sums model for the generalized inverse power Rado Institute distribution, especially for the k equal to 3, 4, 5, and 6. After we run the whole model, we try to check with the density plot. The density plot is mean we will try to check what we will try to check which one is the best from the sum model that we use in this case. Okay, I said before, we have the 4 model here. Generalized inverse power Rado Institute distribution for the k equal to 3 until 6. So to find which one is the best, we can find by using density plot. Okay, we run our density plot. Okay, we try to run the program starting in the beginning. We try to run the program. Okay, we run, we check here. Okay, so all model is runs well. Okay, this one. Okay, we can find there is a 4 colors line here, 4 colors graph here. The green one is mean this is density function for the generalized inverse power Rado Institute distribution for k equal to 3. The blue is mean the generalized inverse power Rado Institute distribution for k equal to 4. The red one is the 4 generalized inverse power Rado Institute distribution for the k equal to 5. And the brown one is the generalized inverse power Rado Institute distribution for k equal to 6. We can find here. The green one is very close with the histogram data. Histogram data is like the bar plot with the color of the gray color. Okay, the green one is so closely. If we make the comparison with the others model, of course, the green one is a very good to the models for the sets data. And then, if you want to check by the minus log likelihood value, we will give the conclusion the lowest value of the minus log likelihood is the best model. Okay, from the density plot, we have success to conclude that the green one is a good model. But if we want to know, we will try to using minus log likelihood to find the best model. It means if we can find the lowest value for the minus log likelihood, it means this is the best model. Okay. To find the minus log likelihood, we only come to the The optim. We come to the optim. Okay. For the generalized inverse power Rado Institute distribution, for the k equal to 3, we just only type the g's. Okay. We can check here. This one is the value of the minus likelihood. For the g's, it means the generalized inverse power Rado Institute distribution for the k equal to 3 have the value minus likelihood 89.3. Okay, we can check with the other models. Okay, with the model. This one for generalized inverse power Rado Institute distribution for k equal to 4. Okay, and this one for the generalized inverse power Rado Institute distribution for the k equal to 5. We run here. And this one generalized inverse power Rado Institute distribution for k equal to 6. We run here. So we check. For the generalized inverse power Rado Institute distribution for k equal to 6, the XTX 0.1. And the another border, XTX 0.5. And this one, XT9. And this one, XT9 too. So it's mean we have the lowest value of the minus likelihood with the model's generalized inverse power Rado Institute distribution for the k equal to 6. So, for this time, we will discuss about the nice concept about the how to improve your model with the adding the once more parameter. We have success to discuss about this one. We try to create the new models, namely generalized inverse power Rado Institute distribution. And we have success to give the data sets. With the data set, we are using the sums model of generalized inverse power Rado Institute distribution. Okay, I think this is nice topic today. I hope our discussion today can give the motivation for my student, of course, or the other students, wherever you are, to always the fights with the reset. Okay, I think this is enough for this time. See you again. Assalamualaikum warahmatullahi wabarakatuh.